Part 5. Use the following equation: y equals x squared minus 2x minus 48. We want to find the x and y intercepts. Finding x and y intercepts is pretty simple if you think about where the zeros go. I'm going to start with the y-intercept first because it's actually the easier of the two. Finding that y-intercept occurs when x is equal to 0. So in other words, I'm going to plug zeros in for x. And I've got y is equal to 0 squared minus 2 times 0 minus 48, or just minus 48. So that y-intercept will be the ordered pair 0, negative 48. X-intercepts, on the other hand, require that you set y equal to 0. So now you've got 0 is equal to x squared minus 2x minus 48. I'm going to think about factoring this. So I need pairs of numbers that multiply to 48 negative, which means one positive, one negative, and add to a negative 2. And the first ones that come to mind to me are 6 and 8. 6 times 8 is 48. They have a difference of 2, which is a good sign. If I want that to be negative 2, then I've got to have a negative 8 and a positive 6. So I now have 0 is equal to x plus 6, x minus 8. Setting each piece equal to 0 and solving, we get that x is equal to a negative 6 and x is equal to a positive 8. And lo and behold, there are two x-intercepts, negative 6, 0, and positive 8, 0. We found our x-intercepts, we found our y-intercepts, and we are only 2 minutes into this problem. And I'm not going to answer that. Sorry. So we go on to part B to rewrite the equation in vertex form. I'm hoping our reminder of how to do this earlier still suffices, but if not, here we go. X squared minus 2x minus 48. I'm going to rewrite that problem right here. I'm going to kind of write it to the side because I want to do it all at once. So x squared minus 2x minus 48, parentheses around the first two terms. Ooh, excuse me. If there were an a value right here in front of x squared, I would need to pull that out in front, but right now there is not. So I'm going to leave it as is. At this point, I'm going to take the number in front of x. That is a negative 2. I'm going to divide by 2. I get a negative 1. I take that negative 1 and square it, and I get a positive 1. That positive 1 is now the number that I need to plug into my equation in order to complete the square. So when I rewrite my equation, I now have the following: y is equal to x squared minus 2x. Take that one we just found, add it in, but oh no, I just added a random 1 to my equation, which right now is changing its value. I can't just add a random 1 and change its value, so if I add a 1, I also need to subtract a 1. These plus 1 and negative 1 balance each other out, essentially looking like a funny looking 0. So with that in mind, I can now factor this first set of parentheses right here, just like we would have done at the very beginning in part A over here. And that x squared minus 2x plus 1 will factor into x minus 1 squared, and then minus 48 minus 1 becomes a minus 49. And we have now written our equation in vertex form.